In this video, I'm going to solve a practice problem using the reaction quotient. In the previous video, I talked about the reaction quotient, Q, and I mentioned that it can be used to tell you in which direction the reaction will proceed to reach equilibrium. So basically what you have to do is obtain the value of Q and compare it with the value of K, which in this case is given here, to know if the reaction is product heavy or reactant heavy, and therefore see what needs to be added. So this is the problem I'm going to solve. We have methane plus chlorine, which is going to form chloromethane and hydrochloric acid. So initially we have 1 mole of methane, 2 moles of chlorine, 1 mole of chloromethane, and 2 moles of hydrochloric acid. And we also know that our K value is 0.04. Finally, this is dissolved in a 250 milliliter vessel. So this is all the data we need. This has to be done at a very high temperature, but that doesn't matter right now. We're not going to use temperature in any of our calculations. So let's go ahead and calculate the reaction quotient. Q is equal to the initial concentrations of the products over the reactants. So that will be chloromethane and HCl over methane and chlorine. In this case, none of them have coefficients, so we won't have any superscripts. That is, if we had two hydrogen chlorides or two chlorines formed, we would have to put it squared. So that is the formula that we're going to use. However, for this formula we need concentration, and what we have is the number of moles. So we have to find the molarity. We have to divide the number of moles over the liters, so 250 milliliters or 0.25 liters. So for the case of methane, CH4, the concentration would be equal to the number of moles, which is 1 mole, over the volume, which is 0.250 liters. So that would be equal to 4.0 molar. Now, because chloromethane also has 1 mole, the number of moles doesn't change, the volume doesn't change, meaning that will be the same for chloromethane. We could just go ahead and write 4. Chlorine and HCl, however, have 2 moles instead of 1, so that would be 2 moles over the same volume, which will give you 4 times 2, that's 8.0 molar, and HCl has the same. Hydrochloric acid also has 2 moles, so we just write 8. Now we have the concentration of each of our factors. We can plug that into our equation. So our Q is going to be 4 times 8 over the same, which makes it 1. That is the Q value. And we said that K was 0.04. So this means that Q is greater than K, meaning that we have a big numerator, which says that right now the system is product heavy. So product heavy, meaning that more reactant has to be added. So when we look at our balance, it looks like this right now. It's product heavy. And more reactant has to be added, so it will shift to the left. shifts to left, and more reactant will be produced. So more reactant will have to be produced or added to obtain or reach equilibrium. And that was the problem. Thank you for watching this video. I hope you liked it and found it useful, and if you did, please be sure to give it a like and subscribe to see more videos like this one.